For the apparatus of the manometer, readily available materials were used and they were chosen for their accessibility, relatability, cost effectiveness, and visual simplicity. 100 milliliter water bottle. The bottom was cut off and the lid was inserted a hole for the air to flow through it. And yes, we left the lid as the 20 millimeter pipe was too small to fit perfectly in the mouth of the bottle. And so on the lid, a perfect hole was made. Supply bottle. Its end was cut, like for the bottle to help air flow through it, and the spring part was left out. The 20 millimeter pipe was too big to be joined to its mouth, so we heated the 20 millimeter pipe and made it cover the mouth of the cleaning supply bottle. 20 millimeter pipe. It joins the 500 milliliter water bottle and the cleaning supply bottle. Surgical pipes. They are attached to the middle of the 20 millimeter pipe, cleaning supply bottle, and 50 milliliter water bottle, and the pipe is filled to an extent with water and is a means of relating the pressure of the three using a T-junction. Vacuum cleaner. It was adjusted so that it could blow air and was the main source of providing flow rates. The final product involves, as mentioned, the surgical pipe joining the other apparatuses through a T-junction. Ordinary superglue was used to make this possible, and the setup was set up on a wooden board which was optional.
Our experimental setup, we finally put it behind the board where we could make our markings and make it presentable. The markings of the heights were done by the sides of the surgical pipes to show the differences in heights when the fluid will be inside the pipes. Special care was taken to make sure that the heights were parallel to each other by using a T-ruler shape. Together with the surgical pipes, they were made to be parallel to the lines that were drawn for the heights of the water in the pipes. The markings were labeled from 0 to 19 cm with each step causing 5 mm increments. The pipes were secured to the board using a super glue, and the middle part, because of its flexibility, couldn't be attached properly, so we decided to use thin metal wires to attach it to the pipe. This was our final experimental setup. We were using a vacuum cleaner to blow the air through our system as our moving fluid, to move the air through different cross sections, thus changing its pressure, of which we can infer the amount of pressure that is within each section by the amount of height that the water would rise within the pipes. We chose to use water as the fluid that we are going to use in our system to measure heights. To make it more visible, we decided to use a tea bag solution with the water so that it might have this brown color to make it more visible. We poured the water in our system and checked for leaks. When we found them, we decided to use plastic and melt it using a heat gun around the edges of the setup so that it might stop leaking. The system was thoroughly shaken and the pipes were vibrated so that the water might stabilize and be on one position altogether. To minimize pressure losses, we chose to use the plastic as a way to connect the vacuum cleaner and our experimental setup in an airtight fit manner so that it might not experience pressure losses. We connected the back of the vacuum cleaner as it provides a blowing force instead of a vacuuming force, and then we used that as a blower in our system to move the air through our system. The initial heights of water in the pipe were checked and recorded.